All right, good evening, folks. We're going to start the meeting here. Welcome to our, I think this is our fourth or third webcast. We have some news today to cover. Some of it is great, some of it is okay, some of it is a little not so great. Do please feel free to ask questions during the entire conversation. There'll be plenty of time for Q&A at the end as well. If you want to hold off on that, that's fine too. I have a few points to cover, and let me just jump into it unless there's some questions. Anybody, Brett or Tara, do you guys have any questions? Okay, then I'm just going to jump in. I'm going to do sure. Shipping, yes. We're definitely going to talk about that. That's part of the questions. And I also have some written questions from folks that sent emails that were not able to attend, but are hoping that this is going to get recorded. And shipping is really a question on everybody's mind, ourselves included. So let me go through the good news first. We have finally negotiated our prospective landlord down into the ground, and we were hoping to be able to report that we've signed a lease today. As it stands, it'll probably be tomorrow. And we're going to post an update about that on the site as soon as we have the keys in our hot little hands. Other good news, we've done a bunch of updates on the machine. By the way, for anybody who hasn't seen the machine in a while, there's been some changes to it. I'm just going to show you guys what it looks like at this point and go through the updates that have occurred so that you have an idea. The big change at the moment is at the top of the machine. It used to be that the power supplies were down here underneath. Now, we didn't have enough space for that. So we ended up moving both power supplies. The one you're looking at right now is the 24-volt DC, and the second power supply over here is the 48-volt DC. There's going to be a cover, a pretty plastic cover here to make it all nice looking, and that's one big change. And then the other big change is down here in the electronics bay. What you see all that blinking and stuff going on. That is a brand new beta or alpha, I don't know exactly which version, but it's a pre-production version of the ASTIG X3 Pro, which is the only board on the market today that currently supports enough hardware for 4 completely independent extruders. So this thing has 4 fans, 4 extruder motors, 4 thermistors, 4 heaters, 4 everything. Okay, wonderful board. We got that from Panacot Devices at the end of January in Burbank, and we've spent the last couple of months trying to get it all integrated. It turned out that there's a little bit of a challenge with this in that the firmware that we were using, Marlin, does not currently support 4 extruders. Doesn't even support 3 extruders fully. It supports 3 hot ends, 3 motors, 3 thermistors, and 1 fan across all of them. So we've spent the last little while getting the 4th extruder and the 4 fan extruders hacked into the firmware. We're still working on that. In fact, just today I was testing that code. So we'll see how that works in the next near while. This is probably what I'll be doing most of this week and probably most of next. For those of you who are sharp-eyed, you'll see that the motor drivers turned around 90 degrees. They fit a little bit better that way and gives the space that the new controller takes up. If you look at the 2 controllers, this is the old ASTIG. I don't know if I can make it stable enough to see. This is the old controller. This is the new controller. The new controller is I don't know, a good couple of inches longer, maybe an inch, like that. So it was a bit of a challenge to get it all fitted in. Luckily, everything fit. and so things are moving reasonably well. For those of you who don't remember, that's the big NEMA 23 X motor. So that, and now the other really big change is that we now have four fully functional extruders with the hot ends down there. You'll see all 4 hot ends. In fact, let me just raise the Z-axis so you can see that a little bit better. Hang on, if my mouse works. 1 second. So. Okay. I have to switch back and forth between the applications, and hopefully that'll work well enough. So you'll see all 4 hot ends there. 1, 2, 3, 4. The very 4th extruder is set a little bit higher. It turned out that there's a little bit of an interference between the 4th extruder and the Z motor right here. That's a problem that's going to get solved on the production machines. This Z motor is not going to be there at all. The Z motor is going to turn around and get hidden inside of this here extrusion. The big extrusion here, that's going to get a lot longer by a few inches. That's not going to affect the overall size of the machine. Probably not going to affect the weight all that much. And then the Z motor gets turned around inside on both sides, obviously. Right? Both Z motors go away. And so when that happens, the 4th extruder will be able to come down, because right now, if it comes all the way down, during homing operations, it runs right into this extruder, into the Z motor, which isn't all that nice. I think I've bent a couple of mounts that way. But beyond that, currently, at the moment, I have extruder number 3, which is this one, and extruder number 1, which is this one, loaded up with filament and hot. If you guys want to, I can show you the extruder extruding. The extruder number 2, that one back there, for some reason the firmware is not driving it at the right rate. So I have to look at the code and see if I've got the parameters set up correctly, just in case. And the other thing that's happening is that you can't really see this change, but deep inside of the extruder, I don't know if you can kind of see in there, there's the drive gear, what everybody calls a hob. We have a new design out, and I think that's probably as much as I'll show for now. So, no, I can show you the machine moving if you'd like. Would you like that? So you can see? Yes? Okay. So let me see. I think I have some G-code commands stashed away here, so I can just type stuff in. So here is the y-axis moving at 130 millimeters per second, and here it is coming back. Again, back out. Now I'm going to move the x-axis. Same way, it's 130 millimeters per second, and back. Let me see here, type this in, and back, and I'll make it come out again, and then I'm going to home the whole thing. Now, during homing, if it's actually moving at a little bit slower rate, we can speed it up, but there it is. Okay. There's one other thing. I don't know, for those of you who are keeping track, we had some shipping problems when we went to Burbank, and the problem was that these two pillars were plastic from an older version of the machine, Bob, thanks for the reason why it's loud and my audio is distorted is because the microphone is right at the top of this camera, so you should be hearing a nice loud knock right here. And as a result, it's actually not pointing at me at the moment. But the point I was trying to make is that these two pulleys are brand new all metal pulleys, and so they'll be much more robust, as well as being better balanced and work really well. So let me turn that around. Well, let me. I was pointing the camera at it, and so the microphone was picking it up from a very close range. Let me do the same kind of a maneuver now that the microphone is pointing at me, so that you can hear what it sounds like in the room. So I'm going to move the y-axis a little bit. Oh, did I just? I probably should have raised the z-axis a little bit. That was the clip you heard, is the extruder running into the glass. I should zero it out at some point. So then moving y back to 0. Okay, and then similarly x. Okay, so that's kind of the actual sound level. How many dBMs would you suspect on the Y motor? I don't know, Taylor. I don't have any tools to measure it with. I guess at some point we'll probably measure that up. But I would agree, it's not particularly quiet. This is not yet a quiet machine. We'll be working on that with the pre-production machines. Let's see. Let's see what I have here on the agenda. Shipping cost, and there was a tricky. Okay, so we'll take a look at that. Okay, so all of that. Which one? Oh, yeah. So that's actually kind of cool. Okay, so Susan reminded me to talk about one other thing. For those of you who've seen the machine before, what you'll see is that the electronics, the whole cabling scheme is much neater now. It still looks a little bit complex and convoluted, and it'll all get hidden away. But instead of loose wires, individual components, there's now ribbon cables. That big loop of cable will get hidden away in the production machine. At the moment, this was just the most expedient way of getting the cabling out to the controller. But all of the connectors are much more solid now, and are much easier to operate and unplug and replug, and everything is modular as we said we were going to do. Okay. Back to that. Oops, I think it just fell off. Okay. So that was all good news. Here's the bad news. As often happens, or as has happened more than once with Kickstarter projects, we're going to be delaying shipping. This is kind of the bad news. Let me explain exactly how we got to that point. When we started the project, we did the following estimate. We started looking based on our own previous experience with renting real estate. We allocated from end of Kickstarter, which was January 27th, to March 1st to sign the lease. That ended up being overly optimistic. Between the legal stuff and the landlord requirements and our requirements, it has taken almost twice as long, a month and a half extra. There was really no way around it, much as I had wanted to. We also had one other challenge. So that's really delayed the start of building out of our facility. I'm really hoping that tomorrow we'll sign the lease, and then Monday we'll go to the township with our electrical plan and start getting approvals and get the electrician in there to start laying down the circuits for the big machines. I'm sorry?
Just so they know we've spoken with the town.
Yes.
That is all in order.
Susan Susan is back here helping out. There she is. Hi. Susan points out a good point that we've spoken to the township. They know we're coming. They know the size and shape of what we need to do. We're doing absolute minimum of work so that we can just get the facility started. And we're pushing any sort of office build out and any of that fancy stuff until later, until we get the production rolling. So the only thing that gets done is electrical work, which is pretty straightforward. It's just running power from the main panel to the places where the machines are going to be. And we're just going to put up some warehouse shelving, and we're going to run in Verizon Fios fiber in there so that we have good internet connectivity there. In fact, I'm really hoping that the next talk we have, we're going to have it right from the facility, so you guys can see what's going on. So that was really one big challenge for us. The other big challenge, and I think we've overcome that. So it's taken a little bit longer than we had hoped, and it's put us a little bit behind the 8 ball. But we believe we've solved the problem, and tomorrow we'll know for sure. Then comes a challenge that we have not solved yet. When we started the project, I went and I talked to the bank, and I went and I talked to Haas, which is our CNC machine vendor. We're going to buy, just to give you an idea, the following equipment is going to get bought. We're going to buy a large Haas CNC mill, in particular the Haas TM2P tool room mill. The reason why we're getting that mill is because it has all sorts of automation, some critical, and it's big. So we can cut 15 machines worth of parts in one go. So when we make a particular part, we're not making just one of them, we're making 15 of them. And that was really at the core of our ability to produce 5 machines a day, which is our stated goal to achieve by fall. So we're going to buy one of those mills. We're going to buy a large CNC lathe. Well, not large, but they're smallest, but still pretty decent size, much bigger than the lathe I currently have, from Haas also, the ST10. The reasoning there is, again, there's an awful lot of automation there so that you can just load bar stock in it and push a button, and it's going to go and make a run of 20 or 30 or 40 parts. We have to manufacture, to produce 5 machines a day, we have to manufacture 20 extruders worth of parts a day, and on a lathe alone, there's probably about 8 or 9 parts just per extruder. So it's a fairly significant volume of work that needs to happen. We chose the ST10 because it gave us a lot of the automation capability, as well as Haas is a pretty well-known name, and there's a good distributor nearby. We went to talk to them, and they said, yeah, sure, we'll make you a deal, and we'll finance your lease. Because that's how we were kind of getting around the fact that we're not raising $500,000. So we got through the Kickstarter, and we started putting in the applications, and Haas basically disappeared. And we have now been able to get a firm commitment from them to fund our purchase, to the point where basically I'm giving it until the end of the month. And come first week of May, what we're going to do is turn around and take advantage of the fact that a large number of people have come to us and asked to see if they can invest in our company. So we're going to go and have a meeting of potential investors the first week of May. And at that point, we're just going to raise the money as straight equity. And they'll write the check to Haas and just purchase the machines. Forget the leasing, forget anything else. In addition to Haas, we're purchasing the following additional machines. We're getting 3 small mills, 3 small CNC mills, tabletop, to make the small parts for inside of the extruder. Those guys are waiting for us to have funding as well for that. And we're buying 2 CNC router tables from another startup here just to save on the money, a company called Makers. And they're kind of a little bit of a stealth, and we're their first customer. But you'll be hearing about them down the road. I wouldn't be surprised if there ends up being a Kickstarter project there as well. So that's kind of our machine shop, plus, assorted other stuff, horizontal, vertical bandsaws, drill presses, and that sort of thing. So all said and done, we're going to raise enough money in May, if it turns out that Haas turns us down, which I think at this point is pretty likely. It will have cost us 2 months, unfortunately. And although I am just curious why they're not giving us the money, in the end, I really don't want to be stuck on that. So depending on how much money we raise, which we're shooting for probably 200,000 or so, we need about 150 of that to finance the purchases that I've just listed. And so we should be able to raise a little bit of extra that allow us to hire a couple of hands in the summer to help us with the build out and just to accelerate getting into production. I see that. Yeah. Hi Taylor. Is there a public invite for potential investors? We haven't considered that, but if you know of somebody who you think might be interested, by all means, please let me know, and we'll get them folded in. Because at this point, I just want to make sure that we raise the money that we need as quickly as possible, so that we don't get into, here comes the end of May and we don't have the money yet. I don't want that situation. So if that means that we're going to invite more people than we can accommodate in this round of funding, then we'll deal with it that way. We'll deal with it on a first come, first served basis, most likely. So whoever commits first gets a chance to be in this round. So we'll probably have, I don't know, my goal is to have 10 to 15 people who are interested in purchasing, those 20, 25, that $200,000, and maybe even a little bit more. So if you're interested, or if you know somebody who might be, then please do let me know, and I will contact that person and set up an invitation so that they can participate in this discussion as well. All said and done, where are we with this? We are a month and a half late in real estate, and we are a month and a half late on ordering the machines. Of all of the machines, the ones that will take the longer are the 2 Haas machines. Those are supposed to take 6 to 8 weeks. Now, Haas delivers, on the average, 1,000 machines a month. So I'm going to say that I'm basically placing some confidence in their ability to deliver on time. Now, that might be unwarranted, but so far, I think I've talked to some folks, and basically on the forums, what I hear is that amongst most of the CNC vendors, Haas has a good reputation on delivering on time. So I'll say that I'm not 100% certain, but if we are able to order the machines in the first week of May, they will be here and up and running in our space by about mid to late June. At that point, it'll take us less than a month to get into production, and we will be rolling the machines out in July. While we're waiting for Haas, we will have ordered all of the other machines. The mills we're getting from TAG, they're promising less than a month delivery, 3 weeks. I don't know how good their reputation is for delivery, so I can't commit to that, but if they deliver the machines even remotely close to what they promised, they will not be the pole in the tent. And the two router tables are going to be built right here in New Jersey. We know the guy who's building them and his startup, and so I'm pretty confident that we'll have that router up and running in less than a month from the point that we're able to order it. So all said and done, all of the other machines, other than the two Haas's, will be ordered first week of May, provided we raise the money, of course. They should be here last week of May, first week of June. The electrical work should be done by then. And we'll start bringing them up and start cranking out parts. I'm actually not going to wait for all the machines to be in place before we start production runs or pre-production runs. So we're going to start running the smaller machines first and start generating parts so that we can take a look and look at the whole process and work on the assembly and hone the process and train people and stuff like that. So we've slipped 2 months. We have, I believe, conquered one of the two major challenges that were in our way. And then the second challenge is either going to be resolved in the original way by Haas giving us the funding in the next week and a half, or else to heck with them, and we're just going to go raise some equity. We've got people lined up and who are interested and eager to invest in us. And first week of May, I really want to be ordering machines. In fact, that's going to be the major indication of whether or not we're going to slip any further. If, you know, at that point, that becomes the only thing that's stopping us from production. So I'm hoping that by the end of that first week, we'll be able to give you another update that will say, hopefully, that the machines have been ordered, and here are the lead times, and off we go. So that's really the meat of the update. I think I've covered everything I wanted to cover. I have some questions from a gentleman by name Pierre-Philippe Stevens, and he's asked the following. He has asked about 3 or 4 questions, but before I get to that, does anybody have any other questions? Feel free to cut in your mics or to type something in. Okay, I'm not hearing any questions, so I'm going to jump into Pierre Philippe's questions. He asked for a schedule update. Your name is on the list, and I've just done the update. So net, I think we are in pretty decent shape to deliver sometime in July. Live demo of the machine, we showed the machine moving. I wish I could show it printing. At the moment, the firmware is still not quite there, and I'm still working on that. Maybe next week we can do another demo. Update on shipping costs, just in case you found some magical way to teleport the machine. That would be really quite excellent if we could. In fact, what I think I'm going to do is I'm going to ask Susan to do a quick update because she was the one who was working with the shipping companies. So
one time I did it, it kicked me off.
Okay, we'll try to unmute and let's see if that works. If not, you can just come over here.
I think I might, hold on. Allow sharing the top of my browser. Hold on, give me 1 sec.
Let me see, can I unmute you?
Yeah.
No.
Oh, I don't know, I might probably stand near you.
Yeah, we probably can.
Let me just find, incidentally, I got an email
Here. Do you want the camera on you?
Not really.
Well, I'll just hold it.
Can they hear me?
Yeah, I don't know. Can you guys hear her? Yes, Bob says we can. Okay.
All right. Hi, Bob. This is for international or U.S.?
I think both probably.
Okay. At the moment, I've been focusing more on international. The U.S., I'm still looking around for, oh, look at the camera. A vendor we can trust. I was able to get somewhere the 24s we were getting better prices for. The 12s, but with that vendor we were not getting any better prices for the 12 and 18 sizes. So still working on that. To me, the international is a lot more scary because there's a lot more involved, and I, hear the stories of things not arriving. So I wanted to find at least a shipping company that was trustworthy and we were able to get some decent prices from. At the moment, just a little while ago, I heard from DHL, who we've been talking to, who says we've just been approved to get more, and I'll quote you exactly. We've been able to get approval to revisit our rates to implement more aggressive pricing. They're currently doing an initiative to help new companies to DHL gain solid footing in the marketplace. So I expect tomorrow or Monday I'll be talking to them again to try to see what's up with that. Other people have also asked about being able to do things on ships rather than planes, because with DHL it's on planes. It seems after 9/11 things have gotten more complicated on doing things by boat. And there's all these approvals and special things to become a known entity. And we've been researching that, but we've not been able to accomplish that yet. And some people have said it's very difficult as a small company. So that's kind of where we stand. We just keep working on getting better prices. We are not looking to make any money from the shipping. Basically, whatever the shipping is, we tell you, you pay us, we pay the shipping company. What we're trying to also do is there is some custom boxes we are making, and we're trying to talk to the shipping companies to see how to make that as lightweight as possible so that this does not add to the shipping cost. And right now also we're somewhat estimating, given we haven't had the printers and the boxes, so I was being a little conservative in that in terms of the size of the box. So hopefully I overestimated, which I was trying to do to ensure that we definitely had the cost. What we will probably do for international, there's tariffs and other things, and we've been advised probably we will do the shipping, and then with the country and the shipping company, once the machine gets there, they will tell you what the price is, and then you just pay them directly to ensure that you don't have to outlay any more than you would with an estimate. You'll just find out what that is exactly. Unfortunately, we've not shipped yet, so we don't know exactly what that will be. So any questions about that?
Taylor, I do see that question. I will get back to the extruder development in a second.
So if you have any other shipping questions, or you have any input, or if you have more experience than do we with shipping the large objects and can guide us in any way, please, we would appreciate any comments or feedback. So did that answer the shipping questions? Yeah,
I presume so. I'm not seeing any questions from anyone. All right, I'm going to take over. Thank you. So let me get back to answering these questions. Taylor, for your question, yes, absolutely. We are definitely thinking of, in fact, at this point, I've pretty much said it to enough. I've pretty much committed to it. We're going to open source the interface between the extruder and the machine. So that will include the physical dimensions, the electrical characteristics, the pinouts of all the connectors, and whatever electronics that we end up putting on board the extruder. That's all going to be completely open sourced. So that's a definite yes. In fact, if there's enough demand, and maybe even if there isn't, we might just put together a kit that will contain the mounting plate that for the extruder, because that's really a bit of a tricky thing to machine. It needs a pretty high tolerance dovetail. And then whatever the controller that goes with the board. Right now, what you see is just a dumb connector board here that I showed you before, right? That little green thing. We're working on putting some additional processing on it so that down the road we'll be able to do things like detect filament out and switch filaments from one extruder to the next. So if you run out on one, you get it on the other, and so forth. So that capability is being for some additional development on the extruder controller. Absolutely. To answer Taylor, you had a question of what amount of technical documentation will come with the machine. Did I answer the question on the extruders fully? Is that sufficient level of detail? Okay. So about the technical documentation, we will definitely cover the basic operation of the machine. There'll be some video tutorials on how to put it together, how to take it apart, how to pack it for shipping, how to put the extruders on, and just sort of the basic operations. We don't want to create a complete tutorial for Repetier. First of all, Repetier is probably better placed to do that. And I think there's already a bunch of tutorials out there on YouTube for how to use it. There's a book about Slicer, and I don't think we need to replicate that. But as far as how is this machine different in terms of operation or troubleshooting or maintenance with respect to other machines using the same software, that we'll cover in an ongoing series of tutorials, probably YouTube. In addition to that, we are going to experiment with Skype-based support. So if you have one of our machines and you run into trouble, then we'll get together and we'll schedule a Skype session, and we'll get together on Skype, and you're going to point your camera at the machine, and we're going to talk you through whatever the diagnostics that need to happen. Okay? We've got pretty decent response from folks about that. That's kind of a unique approach for hardware vendor support. Let's see, what else can I tell you about the extruder development, if anything? Oh, I almost forgot. Wow. Probably the coolest bit of update is that the hotbed is coming. The heated bed is coming. And now I can talk about what it's going to look like and how it's going to work. It's going to be actually probably one of the cooler pieces of gear on the machine. We have found a really good contract electronics developer here in New Jersey. They're about an hour away. And we worked with them for the last 2.5 months to come up with a design and of a heated bed that is modular. And here's what I mean. The basic module of the heated bed is going to be a 6x6-inch square. And there's going to be as many of those squares as is necessary to run the machine of the size that you purchase. So the way it's going to work is on a 12x12 machine, there's going to be 4 of those squares. So there's going to be 4 heated zones. And each zone is individually controlled through M codes in the firmware and in the software, so that you'll be able to set the heat temperature on any one of the zones or all of them, and it will automatically take care of itself. So on a 12x12 machine, you're going to have 4 such zones. On an 18x18, you're going to have 9 of them, and on a 24x24, you're going to have 16 of them. The point and the main purpose of that is to keep the power consumption of the machine down, so that you're not heating the universe if you're only building a 6-inch part. Okay? It's going to be really pretty straightforward to operate, and it's just going to do its thing, and you don't even have to worry about it. You just set it, give it a code or two, and forget it, and you'll be able to, I'll show you how to put those codes into the custom header for your G-code file, and you'll do that once. You'll decide on what you want to do, and if you want to change it, obviously you'll be able to change it, and then just, it'll take care of itself. Taking care of it will be a special controller that will be part of the moving table here. We're doing the physical design of the framework to hold it right now. And basically, it'll be connected to the controller via a serial bus called SPI, and there will be a little bit of code added to the firmware to support it. So, so that's actually pretty exciting news. Let's see, where's the status of that? I talked to the vendor today, and he said that the prototype, the first prototype of the 24 by 24 16 zone heaters has been manufactured. They are on their way to him and should be there end of next week. The controller board has been designed and has been ordered, and should also be manufactured sometime next week. Not sure exactly when. And it should be in his hot little hands by end of next week, early the week following. And so he should have an assembled, tested prototype by the end of the week following next, and I should have it in my hands at that point, and we can start the firmware development to get it up and running. So at that point, we'll have probably the coolest heated bed around. Cool heat. Yeah, Susan just reminded me. Okay, sorry, I didn't mean that to be a pun. I'm not that much of a punster. But anyway, so the point is that the heated bed project is coming to fruition, and it's looking like it's going to be a doozy. So we're really proud of that one. Okay. If there's no other questions, I'm going to jump in with another question from Pierre-Philippe. Okay. So Pierre-Philippe asks that he posted a query on 3D print board. I haven't had a chance to go look at it yet, and then I'll probably answer it in written form there, but so long as I have it here, and I think Pierre-Philippe wants to see this in the, he's going to watch this in the record, the recording. And so the question is, I posted an inquiry here. It's a tricky one, but I'm sure others have similar questions. Two aspects: issues to expect with large prints, and repeatability of the printer. In other words, once I find the proper recipe of parameters, could I print 10 identical objects and they would all print without issues given the same environment? So I think that last part is really really important, is the same environment. And environment in this case means temperature, humidity, and wind. And if you think wind is never a factor, I'm going to tell you that at the last New York Maker Faire, we had a table at the back of the show. I don't know if any of you guys were there, but we were at the back of the tent that was acting like a wind tunnel, and there was wind whistling through there. The table was sitting at an angle. There was rain coming through, and basically, we had to print in those conditions. We were fortunate enough, and the printer worked reasonably well. We had some issues, but we got a lot of help, and so at the end, we were printing reasonably well. So that's the environment. So to answer Pierre-Philippe's questions, frankly, I haven't tried running two parts that are exactly identical, and it is something that we're gonna test. Thank you for bringing that up. It just didn't occur to me. I really am so focused on prototyping and working with prototypes that this sort of series production has not occurred to me as something to test, and obviously it needs to be. So thank you. My own thought here is that the basic 3D motion platform is rock solid. I mean, there's no bends, there's nothing. It's just straight and rigid, and it's going to move in exactly the same way. One of the ways that one of the things that we have done in this regard is we've done some repeatability measurements on, you move the table 100 millimeters one way, you bring it back, did you get back to the same spot, right? And so far, within our ability to measure, which is about 20 microns, we can measure to about 20 microns plus or minus. Within our ability to measure, repeatability is essentially 100%. We couldn't measure an error. So that puts an upper bound on the error. This is kind of one sort of huge advantage of ball screws. You go out 100 millimeters, you come back 100 millimeters, you're back to where you started from. And it doesn't matter how many times. I've tried moving the table, 20, 30, 50 times back and forth, literally at full speed, back and forth, back and forth, back and forth with a G-code script. And I cannot detect any deviation from, X0 or Y0 or whatever. So just based on that, I would expect the motion platform to work exactly the same way. So what's left? We've already talked about the environment. If the environment can be kept roughly the same, meaning roughly the same temperature and humidity, great. You can't control wind, other than in an office, there's probably not that much of it to start with. So that's good. If you're printing outside, then you might have some challenges. Which really leaves us to two sources of potential errors. One is filament and two is extruders. At this point, we've run extruders for, I think the longest I've ever run one of these extruders is about 28, 29 hours with no noticeable problems. Ed, one of the other guys, which I was really hoping that he would join us for this talk, maybe give a little talk about our extruder technology, but maybe next time. So Ed, he's the guy who's the engineer up in Toronto, who was the key designer on the extruder part of this. He said just the last 2 days, he went through over 1 kilo of filament. So that basically means nonstop printing for basically whatever, for 48 hours. And he said, no problems. The extruders are holding up just fine. So I don't think I'm comfortable guaranteeing that everything will be perfect, but I think the odds are that those 10 parts will come out reasonably well. Certainly dimensionally, they'll be fine. The only real concern I would have is filament. And here's the big concern. Most filament materials, well, not most, but the two main ones, ABS and PLA, absorb water like crazy. Vendors make it really clear. PLA vendors, if anybody's interested, I can ship you an article from like a vendor on how to treat PLA correctly. And basically they say, any filament that's been out of a vacuum pack for 20 minutes is absorbing water. Okay. Similar things are true about ABS. Less so for PET and nylon. Okay, I'll send it to you, Taylor. Let me know, Brett, if you're interested as well. So basically, once the spool of filament is on the machine, it's absorbing water. Once it starts absorbing water, it is entirely possible that that does not absorb it evenly, because there's variations in what the plastic, in how the plastic is manufactured. Once that happens, that could potentially affect the print in unpredictable ways. The only way to really know is to test this, and we're going to do that. So we'll let you know what the results are once we get to that point. Other materials are actually somewhat worse. PVA, which is the support material that works well with PLA, PVA is worse than PLA, and it should be. It's unfortunate, but that's the side effect of the fact that it's a really great support material. Right? It absorbs water, and because it dissolves in water, so humidity really makes a huge difference for PVA. That's kind of a long answer. If I were to summarize the repeatability answer is, from the mechanical perspective, from the 3D platform motion perspective, you should get very good consistency, really good consistency. From the standpoint of the extruder, you should get pretty good consistency from what we've tested so far. From the perspective of the filament, I honestly don't know enough, and I can easily see that depending on the filament you use, the supplier you use, and the quality of that filament, you might see some issues. And that's independent of the size of the print. And obviously we've talked about the environment being an important factor as well. So that's that answer. A more open question is, what are the issues that we can expect with large prints? That really depends hugely on material. If you work with PLA, then there's a lot less issues once you get it tuned up. There's a lot less issues because regardless of the size of the print, or almost regardless of the size of the print, PLA does not warp as much as other materials. And so it doesn't shrink as much when it cools. And so you should have fewer problems with it than with others, even on large prints. We've tried my favorite thing. I mean, this vase right here is, I don't know, it's about 10 inches tall, and it's about 11 or 12 inches wide, and, whatever. This thing just basically printed and went on and on and on for however long that was. I don't even remember. If you use other materials, so for example, ABS, that's a well-known material that has problems as you scale up. We don't know yet what large prints will look like that are tall, right? That's my big concern, is that tall prints will start warping as they get taller. We don't yet know. We will certainly test that and see how it works out. Materials like PET and PLA and nylon are reputed to have fewer problems even as you scale the print. Again, we have a box full of this stuff here. As soon as the machine is, as soon as I'm happy with the upgrades working well, then at that point we're going to start testing the large prints with nylon and with PET, and hopefully we'll figure out what the consequences are going to be. So the biggest by far risk in large parts is that the differential cooling of the part is going to result in delaminations or in warping of some sort. So far with PLA, I have not seen that. And I believe that the 10-inch print like that vase should have shown if there are any delamination issues. We're going to try some bigger prints in a little while, and so hopefully whatever the problems crop up, we'll run into them and try to figure out how to get around them. But that's kind of what to expect. That kind of brings me to the end of my own agenda and Pierre Philippe's questions. So I'm really hoping to hear some questions from you guys and any sort of feedback on what's going on. Feel free to cut in with a microphone and let us know. Brett, any questions or comments or feedback or anything else? For Bob?
No questions from me, Ben.
Oh, all right. Cool. The mic works. Okay, thanks, Bob. Absolutely. What we're going to do is as soon as we got the firmware wrestled down to the ground, I'm just going to make a video, post it on YouTube, and spread the link around. Oh, for the record, Brad asked a question that made the comment that looking forward to seeing the printer printing next time. Even 2 extruders would be great. Yeah, absolutely. Oh, actually, speaking of that, there's an interesting bit of new development on that front. For those of you who have been tracking Slicer, their newest upgrade has a really cool feature. This is something that hasn't existed before, so I'm going to talk about that for a couple of minutes. Used to be that Slicer only knew how to automatically assign 3 extruders. It would use perimeter for one extruder, infill, another extruder for infill, and a 3rd extruder for support. And that was a great start. But then they noticed something that's kind of unfortunate. Turns out that some of the support material is actually more expensive than the main building material. In particular, PVA can easily cost $44 a pound, whereas PLA is typically more, between $14 and $25 a pound. So they also noticed that often support material for some parts, for some objects, could actually be bigger volume of material than the main part. It makes no sense to print everything using the expensive support material. So what they did is they've added a capability to use a 4th extruder. And the 4th extruder is assigned to support interface. So think about it. Let's say you have a part with an overhang like this, right? This is just a piece of aluminum. And so you want to print this. So now you have to build support, scaffold, a support scaffold right here, okay? I'm trying to do this without pictures, but just examples. So if you do that, then the part itself is a fairly small volume, but the support material needs to be this whole area, right? And that's just going to be too expensive. So by using the new capability, what you can do is you can use the cheapest filament you have for the bulk of the support material, and then the part of the support material that actually touches your part, the layers, right here. Can everybody see that, Miles? That white layer, the extra layer here, can be made in a different material. And here's what that buys you. You can use the cheapest material you can for the bulk of it, and then just the top layer gets built out of the expensive material. So that's just for the support. That's right. Correct. So the end result is you still get all of the advantages of support material, but you're not spending as much money on those parts where the overhang is large and where the support material would otherwise be too expensive. Now, obviously, if the part you're making, is one of those little gearboxes where the 2 gears are 1 millimeter apart, and all you need is that tiny little bit of support material in there to keep the part separate, obviously you don't need that capability, right? This is for, large sculptures with overhang like this, where you need to build up the material all the way up. And I think that's really a very exciting new capability. I can't wait to try this out. Absolutely can't wait. So that's a little side conversation. Anything else? Does anybody else have any other questions or comments? Oh, Ed just showed up. Hi, Ed. You just showing up just for the end of the conversation. Can you hear us?
You want to tell who that is?
I'm not hearing him. But Ed, if you can hear me, let me just do the introductions here. Ed Nesterov is up in Richmond Hill, Ontario, just north of Toronto, and he has been the driver behind the extruder technology development that we've had, and also pretty much the sounding board and a big part of the development team on the 3D motion platform. So it's great to have him join us and maybe introduce himself. Ed, can you hear us?
Can you unmute him?
He's not actually muted. There's just kind of a little yellow icon next to him, which I don't quite understand what that is. I heard a ping. And I heard him mute himself. Let's see if he can unmute himself. Ed, I see you unmuted yourself.
Yep, I am.
There you are. Excellent.
I am unmuted.
Excellent. So, just to give you an idea, I've talked about a lot of stuff today, and can you just sort of introduce yourself a little bit and talk a couple of things, say a few words about your background, and maybe talk a little bit about the kind of capabilities we're working on in terms of the extruder technology?
Well, my name is Ed Nesterov. I'm working on the extruder part of our printer, and I have background in engineering from old world, particularly from Ukraine, and this is about it. The new directions that we're trying to follow with extruders is we are trying to make our extruder as easy to use as possible, and we strongly think that one of the mandatory features to accomplish this is to make it modular. So you have drivetrain separate from the extruding part, and you have extruder which is separate from a drivetrain. And this is exactly what we're working on at the moment.
So just to give folks the idea of what that might look like, let me see if I can take one of the extruders off of the machine and show you a little bit about what to expect. So if you look at our extruder as it stands today, right, I'm touching what is a hot end. Obviously, it's not hot, right? So this part right here, this portion, is the drivetrain from all the way from back here to here. There's a gearbox in the middle, and there's the actual, you can't really see inside, but the actual transport mechanism is in there. And then there's the mounting, And then this is the hot end. Right here, there's the heat sink and the heater cartridge and the nozzle, and there's a tube inside that transports the filament from the drive train down into the nozzle. So what Ed is referring to is we're experimenting with taking these components, especially the hot end, which is working really pretty well right now, and the drivetrain, which is this part right here, and separating them into two units so that with a quick connection between them. And the basic idea is that by doing so, we can make it really easy to just remove the motor, the entire drivetrain, look inside and clean everything up for just sort of preventive maintenance. Or if you need to replace any parts, you don't need to take apart the entire extruder. You can just take apart into two halves and then work on each half individually, which makes it a lot easier for any sort of part replacement or adjustments or anything else like that.
And let's not forget about cleaning because, all filaments that you can get on the market are different. And not even that they have different physical qualities. Even same filament within the period of couple of weeks will behave differently inside of extruder. So today it's flexible, it's nice, there is no shredding or anything going on inside the extruder. Tomorrow it dries out or it wettens and suddenly you get all sorts of tiny little plastic dust inside of the extruder, which you really want to clean. And not everybody has compressed air. Not everybody can use compressed air in the office, for example. That's why we think that if we can separate it in half, if you can always detach the drivetrain from the hot end and go blow it with compressed air and put it back and you're done. So that's the main idea.
Yep. So that's kind of the direction of it. If we're able to make that design change before we go into production, we'll then offer the ability to add the new configuration extruders in the future, and we'll probably do a trade-in or something for those who buy early. I'm kind of hoping we can get this done before we go to production. In some ways, the fact that we're slipping production a little bit here will give us more time. We'll give Ed, I shouldn't say us, we'll give Ed more time to get that design squared away and ready for production. So hopefully these new sort of somewhat more modular extruders will show up for your machines. Thanks, Ed.
No problem.
Okay. Does anybody have any other questions or comments or anything else? Okay. In that case, we're going to wrap this up for tonight. Thank you for joining us and for your questions and your feedback. And we'll try to have another update at the end of the first week of May, at the most into the second week, whether it's before we go to San Francisco Maker Faire in mid-May, to give you an update on the fundraising and the machine or the ordering of the machines. In the meantime, if you have any questions, do please call or write or email or something and let us know. And thank you for joining us tonight. Good night, everyone.
Good day, guys.